So my name is Andy. I'm an evangelist at Unity Technologies, and I'm going to be talking today about shader graph. And thank you for everyone waking up early to come see some shaders. So the session topics I'm going to cover is setting up shader graph in a Unity project. So open up the editor and show you what you need to do. The overview of the shader graph interface, how it works, its workflows. Creating interesting visuals by combining various built-in nodes very easily and very quickly. And other extra resources and information just to show you where you can get started and how you can learn to make shaders using shader graph. So to give a bit of background, shaders are basically a script that sets the color of a pixel on the screen. And these are used for everything that is rendered, from meshes, sprites, UI, particles, even post-processing. And this is incredibly important if you want to create a certain visual for your game or have a certain art direction. However, this artist-focused approach or artist-focused topic requires lots of coding, knowledge of complex maths and algorithms, and knowledge of technical rendering. So here we have a problem. We have artists who want to design some kind of visual style for their game, but they have to learn a lot of coding, a lot of things they don't want to learn to make their game render in a certain way. So anyone here who doesn't like code, close your eyes now for this slide. So here is a typical example of a shader, which has a bunch of libraries, different parsers, different settings. And it seemed very strange to everyone, and especially us at Unity, that you would have to write a lot of code like this to create some kind of visual for what something looks like on screen. So we addressed that by basically creating a tool called shader graph. And shader graph is available in Unity 2018.1. And the interesting thing here with shader graph is we try to make creating shaders and creating visual effects as visual as possible. So visual that actually I've set up the code here on the left is basically the same effect as the shader graph on the right. So as you can see, it's taking something for artists is intimidating and making it a lot more appealing for them. So some quick information. It's a visual interface to create shaders using absolutely no code. It's developed by Unity's R&D graphics team. So it's actually created by us, first party in Unity. And it includes a library of built-in nodes. So I don't remember the exact number, but I think it's something about 200 nodes built into shader graph for you to use from the beginning. And it also includes an API to create your own custom nodes. So for those of you who like writing code, you can actually script your own custom nodes directly for shader graph. Pretty cool. And it's available in Unity 2018.1. And you can get it by the package manager directly inside the Unity editor. And you saw in the keynote John Elliott talk a bit about scriptural render pipelines and the new graphics that we're adding and new rendering architecture. And shader graph is tuned to export shaders for these render pipelines, such as lightweight render pipeline, which is supported today, and the HD render pipeline, which is currently in development. So I'm going to switch to demoing now because it's a lot more fun than boring slides. So here we have a typical spider robot character. If I go into play mode, you can see that he or she just looks around, not particularly appealing. And this robot, if I select its material, is currently using the lightweight standard shader. So this is the standard shader set up for the lightweight render pipeline. And what you'll notice is the lightweight standard shader already has a lot of options for the user, such as albedo, metallic, normal, and other settings. But these only cover some certain uses of games. And what we want to do is we're going to create an interesting visual effect for our spider robot. So once you have Shader Graph installed, to create a new graph, go to the Create option in the project folder, go to Shader, and you'll notice here that we still have options to hand write your own shaders via code. If you still want to do that, that's perfectly fine. But we also have options for a PBR graph, a subgraph, and an unlit graph. So we're putting both the handwritten code shaders and the graph shaders basically together. So I'm going to create a PBR graph. I forgot what robot spider is in Korean, so I'm just going to write it in English. So now that we have this robot spider graph asset just here, to basically open up the graph, and this will be very bright on the screen, you double-click the asset. Sorry. And we have here the graph interface. And you'll notice there are 3 key elements to this graph interface. Probably the most important one is this middle one here. And this is called the PBR master node. And the PBR master node, or the master nodes in Shader Graph, is basically the end point of the Shader Graph flow. It's what all the different effects do when they are exported out to the shader. And because Shader Graph works on a left to right basis, kind of like reading from left to right, this bit is basically the end of that shader's sentence. And you'll notice on this master node that there are a different couple of outputs. And if you've used PBR rendering or the standard shader in Unity, you'll notice a lot of these are probably very familiar. So we have albedo, normal, emission, metallic. We have other options for opaque transparency, different metallic workflows, even different type of blend modes. And we're basically exposing a lot of options that you'd normally have to write via code to access. I'll talk about the other 2 areas in a minute. So now that we have this PBR master node, what we can now do is create nodes in Shader Graph and connect them up to this master node to do different things. So to access the node library, you can right-click anywhere in the Shader Graph editor, and you'll notice here we have a Create Node option. And this will reveal a menu of all the different nodes built into Shader Graph. As I said earlier, there's probably, I think, 200 or so, and if I was to go through and explain them all, it would probably, this talk would be about 7 days long. So I'm only going to show a few. So as you can see here, we have options such as an artistic menu, and inside here you have more options. And inside here we have even more options, such as nodes to control the contrast, or the white balance, or various different options that you want to apply to your shader. I'm going to cheat, and I'm going to use the search option at the top. So I'm going to create As I type in, you'll notice I can type mu, and it will filter all names of nodes that have mu in it, so you very quickly can find what you would like. And I'm going to use this to create a Fresnel effect node. So as you can see here, we've created a Fresnel effect node, otherwise known as rim lighting. And a node has a couple of key elements. So the node on the left-hand side, just here, is basically the inputs into the node. And on the right side is the outputs from the node. And what each node does is it takes the value and data from the inputs, in this case, normal, view direction, power, so you can actually change the rim power. It applies it to some code in the back end in the node, and then it outputs it out the other side. So if I wanted to apply this Fresnel effect to this shader, I can actually just select this connection point here and connect it into the emission map. And what you'll notice is now these are connected, and the effect is being applied into this master node here. On the right-hand side of the screen, you'll notice that we have another sphere, and this is what we call the preview. And if I right-click it, I can choose different meshes that are used to preview our end shader. So if I go to capsule, we can see a capsule with white rim lighting, or a cylinder, or a cube, or even a custom mesh. So if I now choose the head of that spider robot, we can then preview what our shader is going to look like in the graph without having to go back and forth to Unity all the time. So this effect is a little boring. It's just a white outline, so I'm going to apply some color to it. So if I open up the node menu again, and let's search for color. So we have here a color node. I'll pick green, seems pretty cool. So I want to basically take the Fresnel effect node and the color node and combine them together to make green Fresnel. And we can do this by using a basic multiply node. So we just have this effect multiplied by this will result in something else. It's just basic this plus this equals this, or this multiplied by this equals this. So I can grab the connection, bring it to the multiplying slot, grab the color, bring it in here, and you'll notice that we have the Fresnel effect and the color now combined to create green Fresnel. And I can output this into the emission slot as well. So you can see here that as I'm connecting nodes, Shader Graph almost instantly will show you what the end result is, including on the end preview mesh on the right-hand side. So this is probably the most basic shader graph you can possibly create. So now that this is made, I'm going to go back into the Unity editor and see what this actually looks like. And to do this, every time you'll have to select this Save Asset option in the top left-hand corner. So if I go back into the Unity editor and select the spider robot's material, if you go into the shader drop-down list, you'll notice that currently there's a menu option called Graphs. We are actually working on it, so you can set the menu file path. And if we go into Graphs, you'll notice that we have a bunch of different graphs that some I've already pre-made, including Robot Spider Graph. And as I set Robot Spider Graph, our robot now has a green Fresnel effect. Pretty easy, right? Now, one thing to notice is that the material inspector doesn't have any options exposed. There's no color for what we want the Fresnel effect to look like, and there's no power setting either for how intense the Fresnel is. And we need to expose these properties so we can tweak them for each material. So if I go back to my graph, what you'll notice here is that this power value, I can actually change this power value, and you can see that the end result is actually being applied all the way through. We want to expose this power value as a property and expose this color as well. And this is where this top left-hand menu comes in use. And this is called the blackboard. And the blackboard's very useful because clicking the plus will expose all the different properties that we can expose. Kind of think of them as your variables for your shader. And if I select a vector1 property, which is just a number, I can then call this Fresnel power and set it to a value. And now that we have this property in this blackboard, I can drag this property into the node board like so, and connect this into the power slot. So now this value is hooked into here. This is basically our entry point. So if I set this to 10, it's going to change. 0.1. It changes. You can see that this value is now being used across the shader. And similarly, you can also take some nodes, such as this color node, right-click, and convert this into a property the other way. So if I convert this color node to a property, notice here it has now become a color, Fresnel color. It also has that same green value, and I can still choose the color slider, and as I move the color slider around, let's set that to 1. You notice that the previews are all updating accordingly. So this is basically our variable in use in this graph. So I'm going to save the asset, go back into the Unity scene view, and you'll notice here, Fresnel power and Fresnel color are now exposed for us to tweak per material. And this is very useful because you can obviously preview a lot of things directly in ShaderGraph, but you're going to want to see what the results are like directly in your scene view. So going between ShaderGraph and the Unity scene view is very important. So now I can tweak the color. I'm going to set it other to the error color. And let's go with a nice green Fresnel. So very quickly we can create a shader graph, expose it, and then tweak some values to see what it looks like. Now, our spider upper is actually quite boring. We want to be able to apply textures and other things to it. So I'm going to go back to the graph. Sorry about it being super bright. And if I go to the Blackboard window, you'll notice here that we have other options as well as vector1 and color. We have texture, cube map, and even Boolean for little toggles. And I can choose texture, and let's call this spider texture. So we now have a texture being applied into our shader graph. Okay. Let me just move all the nodes down. So I can drag this texture into the shader main window. So this property is now in our graph. And here we have this spider texture property. And you'll notice that it has a type of T, basically meaning this is a texture. And if I want to then apply this to something, such as output this to the albedo node, slot, you'll notice it's not actually hooking up. It's not connecting directly to it. And that's because we have to take this texture and convert it into something that shaders can understand, which is RGB values, color. So rather than some people being confused, we've actually created the menu that's created when you drag and let go to recognize what data you're putting in this case a texture, and then it then chooses or filters the list to what textures, what the data is, what nodes are compatible with this data. So here you see the menu list is a lot smaller, which is good. We don't have to go through 200 nodes to find what one we need. If I go to input and texture, we then have sample texture 2D. And you'll notice here that the input, let me just tidy my graph up. The input is the texture and a UV, and the output is RGBA plus also red, green, blue, and alpha channels. So it's taking that texture and it's converting it into colors or channels that we can use in our shader. So if I go back to the blackboard, you'll notice that there's no texture being used. And if I click the target and choose Spider Robot texture, you'll notice that the preview will show you what texture is actually being applied to this node. And I just want to say again that we've really tried hard to make almost as many nodes as possible to have some kind of preview to show what is actually happening. So rather than making some nodes and then guessing what it's doing, you can instead apply a texture and then see what the end result is almost straight away. Oh, hang on. Okay. And I can then connect this to the albedo slot. Straight away, we can then see the texture being applied to our spider robot. And when I click Save Asset, you'll notice here that we have spider texture slots automatically added, and we now have our spider robot with a basic rim lighting or basic Fresnel effect and color and texture. Pretty cool. So these are just a couple of tricks that you can use in Shader Graph to use built-in nodes, but also get textures into Shader Graph to create some kind of effect. But the next thing I'm going to do is I'm going to use a lot of built-in nodes to create some kind of dissolve effect or dissolve transition. And I usually use dissolve as a good starting point for shaders and Shader Graph because it uses a lot of built-in nodes, and it's a really fun effect to be able to play around with and experiment with. And it looks pretty cool to show you in this demo. So if I right-click in this space and go to Create Node, so one very common algorithm or one very common thing used in games is noise. So if I type noise into the shader library or shader node library search, you'll notice that we have two types. I'm going to choose simple noise. And what you'll notice here is that we have a simple noise node with an input of a UV and an input of a scale. So you can actually change this and see what it looks like. And what noise does, if you don't know about it, is it's basically an algorithm that kind of creates sort of randomness across various directions. So think of it as kind of like used for making waves bumpy in water, or actually in the Book of the Dead demo with the grass, rather than all the grass moving side to side at the same time, they applied noise so the grass was slightly offset. And you can use it for clouds, you can use it for lots of interesting different effects. And with this noise node, it generates this noise node, it generates the noise for you, so you can actually adjust how much noise you want and how large the noise algorithm is. And what you'll notice is that there are some areas that are dark or black pixels and some areas that are white. So a value of 1, and then there's all the different shades in between those two colors. So think of it as white as the tops of mountains and black as the bottom of mountains. So it's kind of doing this across the noise UV. And we want to use this noise. We want to have our spider robot dissolve in and dissolve out. So another common function that's in shaders is a step function. And we've added that as well. So step, it's probably better to explain it when I actually plug it in. We'll basically take the input and it kind of returns a value that's either, it's kind of like a true or false. So it takes a value, and if any colors or values are above that, then it returns 1, or in this case white, and any values beneath it, it returns black, or in this case 0. So we're taking built-in noise and built-in step, and we're creating this kind of patchwork effect. And let me just create a slider node just to show you what it's actually doing. So it's basically doing this very basic effect. This is just with 2 built-in nodes directly in ShaderGraph. And of course, I can also adjust the scale and then actually see what this looks like at a greater scale. So all directly built in without any code. Now, some of you are probably thinking, I have no idea what noise or step does. You've confused me already. I don't know what you mean. And that's okay. What we tried to do with ShaderGraph is take a lot of very common terms and principles in shaders and shader editors and bring them into ShaderGraph. So if you see someone say, just use step for this, you can actually Google step shader and find lots of information about the step function and what it does. So we're kind of using all that information that's already out there on how to create shaders. And another really cool thing we did is every node has a documentation page. So if you right-click it, you can actually select Open Documentation. And of course, my internet is not working, so I preloaded all the pages in advance. So for example, here is the step node, which is quite a basic function, where we have here a description of what the node does, the inputs and outputs, and then also the code that's underlying in the shader. So it's saying here, it steps these 2 values. And similarly with noise. Okay, some of you who don't like coding, probably close your eyes at this point. But for here, for example, if you don't want to know what a node does, you can right-click it, open the documentation, and you can then see the actual code that's happening in the background. You don't have to write this, it's already pre-written, but it's very useful to know what the node is doing in the background. So if I go back to ShaderGraph, we now have our noise and our step, and we have this pretty cool dissolve pattern. So if I take this dissolve pattern and I output it into the alpha clip and set right to 0.5, we then have this very basic dissolve effect. And what you can see is as I'm adjusting this value, you'll notice that everything is very visual. You can see here this setting here. You can see on the end of the master node, and we can also see here in the preview. So let's look at it from the left-hand side. And of course, if I change the noise scale, it's also being applied onto all the results. So one thing you might notice is that as the spider robot is partly dissolved, like so, you'll notice that you're not really seeing the inside of the spider robot, which is quite a common thing you want for dissolving effects. So we decided to build in a checkbox. Just click this, and there you go. You now have a 2-sided dissolve. So you can see it now inside the spider robot as it's being dissolved. So we try to take a lot of things where you'd have to write a lot of code or do a lot of research and put them into a tick box. So now that we have this dissolve slider, I want to be able to tweak this on the material asset. So I can right-click, convert this to a property. Let's call this Dissolve Effect. You notice here that this vector1 property is also going to set up a slider directly in the material in Spectre. And we also want to be able to tweak this noise scale as well. So I'm going to create another property called Dissolve Scale. So we now have our Dissolve Effect and Dissolve Scale exposed as properties. So I'm going to save my asset. Let's go back to Unity. And okay, it's already partly dissolved. You notice here we already have Dissolve Effect being rendered as a slider straight away, and we also have Dissolve Scale. And now I can make tweaks and view what a spider robot looks like with various dissolving. So if I now increase this value quite a lot, we have a very basic dissolve effect, all built entirely with built-in nodes. Pretty cool. And you can actually do this all at runtime as well. So there we go. And of course we can also change the color. So let's have a nice red dissolving spider robot. So yeah, you can use Shader Graph to build effects very quickly instead of having to go away, find a noise library, find out what the step function does, and plug them all together. So there's a couple more nodes I want to show you. So we have here this simple noise, and this is using the UV channel for our spider robot. So it's basically taking this effect and cutting it out of this texture. So imagine these two things being overlaid or multiplied together. We maybe don't want to do that. Instead, there's a really fun node you can use called Position. And what Position does is it takes the object and its vertices and where it is on screen, and it automatically creates the world space position, so where it is within the world, the view position, so where it is on the screen, its tangent, and various other options. So we want to get the position of where it is in the world. I can just create this node, output this into the simple noise, and you'll notice that everything, let me do that again. So everything is using UV channel 0. And as soon as I connect this, everything instantly changes to see what the result is, straight away. And now if I save this asset, let's go back, let's dissolve our spider robot a little bit. Now as I move my spider robot around the scene, it's actually applying that noise rather than wrapped around the UV, it's applying it in its world position, so I can actually move it up and down. Or let's even go into play mode. Close, okay. So you notice that as the spider robot's looking around, its position is moving around in world space. So very quickly with that one node, our effect has changed almost completely. So let's go back to here. Let's do something else. So rather than just having world position, let's go to view position. Save that. And what you'll notice now is our dissolve effect is now being applied to not the UV and not the world, but it's actually being applied to the screen. So you'll notice that as we move it around, the dissolve is basically locked to the position where the camera is. So let's set this low, and then now we have this kind of creepy dissolve effect, but being applied in camera space. And yeah, so very quickly you can get some very interesting, very strange effects just by plugging in different nodes and seeing what they do. And if I go back to world, we can also do things like play around with the UV. So if I create another node And let's use something such as twirl. This will take the UV and it will distort it and twirl it to kind of create some kind of twist. So I plug in this value, I plug this in. Did you see that? It straight away changed. So you'll see that you have, this is what it will look like using the world space node. As soon as I plug this in here, watch, straight away it will then show you exactly what it's going to look like. And we can also adjust this value so you can actually see poor spider robot. So now, if I go back to here, whoop, we now have this dissolve effect being applied. Now move the spider robot too high. And let's lower that. So you have this pretty cool effect already being applied just by connecting a couple of nodes together, all on stage, which is pretty cool. And I think because this is in world space as well, you can move it around and it's kind of scrolling through the effect. Pretty cool. So you can connect different nodes together to get different results. And that's actually what I found is very useful in learning shader graph, is creating nodes, creating different, using the built-in nodes, plugging them together and seeing what the results are. So if I now switch to this project, this is a shader graph example library that we have released on GitHub, and I'll put the link up to this library at the end. And this is basically a resource for you to look at different examples and see what they are, see how they're put together. So I have the same character all in a line. Some are using some effects you already know, in this case, rim lighting. Some are using some other more exotic effects, such as this scrolling water. This one's from an Apple commercial. No, not very funny, I guess. So you can see here, you can actually adjust the gradient of this robot. Here is using this kind of sliced effect. This is actually a shader that is in our shader documentation, which I ported over to shader graph. And here is some kind of snow where it's using the world normal up to apply a snow layer to the top of the robot, to the top of the character. So as I move the character around, the snow is always being applied to the top of it. This is basic toon shading. And this is dissolve as well. But it also has a very thin colored edge. And it's also using this texture as opposed to noise. So I could actually apply, let's go with this effect here instead. And the reason why I'm showing you this is that you can look at the different effects, such as this scrolling hologram here, inspired by Star Wars. Open up that shader and then see how that was put together. So you can take that and then put it together and apply it to your different effects. And because these shader graphs are basically their own windows, you can actually take them and apply them like so. So now we have our scene view and shader graph here docked somewhere in the Unity editor. So you can tweak your shader, save asset, and it will update straight away into here. So let's say, for example, I remove scrolling and then save the asset. Instantly it changes. So you can see very quickly, change the shader graph, save it, and then you see what the result is. Let's connect that back. And the other cool thing about shader graph is here we have open one graph, in this case the scrolling hologram. And if I then go to this Apple commercial, or in this case this gradient, I can open up this graph as well. So you can actually open up multiple shader graphs at exactly the same time. So you see here we've got both the gradient and the scrolling hologram open at the same time. So you can edit both of them. You can also copy paste nodes from one to the other, and use them as a reference. And this is going to be incredibly useful for someone who creates an effect online, or you use the example library, you see how the effect was done, you open up your graph, and then you move things over or experiment with different things. It's very, very cool and very visual. I can even do something like, let's open another one, because let's take snow. So we're going Inception with shader graphs. There you go, 3 graphs open at the same, like you sort of see the point. It gets a little busy. So I will now switch back to my slides. So that's the end of the presentation. So a couple of other bits and pieces. Shader graph is available in 2018.1. It's available as of 2 days ago. You can get it by using the package manager in Unity, which is underneath Window and Package Manager. When you create a new project in Unity, there is now a lightweight template. And when you install the lightweight template, this will automatically have shader graph in your project. And the other really cool thing is that shader graph and its code is all on GitHub. So if you go to that link, you can actually open up shader graph, see how it's put together, and it has all the source code for the nodes. So when you want to write your own nodes, you can actually look at all the source code of nodes and how they were constructed. There's one other resource I want to show you, and that's this blog post. So those of you who are programmers or developers, there's this blog post on how you can create your own nodes in shader graph. So it's a step-by-step. I'm not going to go through the whole tutorial, but if you go to the Unity blog, you'll find this custom node API blog post, which is very useful for creating your own effects and sharing them with your team. Sorry. And at the very bottom, when this goes away, you can see here that example library I showed you with the lineup of all the characters is available on GitHub to download. So I urge you to download it, experiment with it, try it out. Send me an email. My email's in the README if you have feedback or suggestions or changes and things like this. Or if you use it. If you use it, I love seeing when people use the things we make at Unity. So let us know. And there's a guy called Kijiro who works in our Japan office. Some of you have probably seen his GitHub repository. It's amazing. And he's also creating some examples as well. So there's already lots of resources already out there for you to experiment with and try out. So that's the end of my presentation. I have a couple minutes of questions, and I just want to say, 감사합니다. Okay, there's a couple of questions. So one of the questions is, can we get the graph material to shader code? So how can you view the shader code that is generated? And I will show you very easily how you could do that. So this is already automatically generated. Now, if I select this and, could I switch back to the screen, please? 감사합니다. So we have this end master node, and this is the result of our shader. And if you right-click this node, this is a little trick. I think we're going to make this more obvious. And you select Copy Shader. Open up Sublime. So you then have the generated shader. Of course, because it's generated from a graph, there are some elements which might be a little odd or need some tweaking or a little strange, but that is then that generated shader. So you can actually take this and then tweak and modify it. However, if you then tweak and modify it, it won't go back into shader graph. It's kind of a one-way street, but we're always looking at how we could make this workflow a lot nicer in the future. So as you can see here, we have Fresnel power, Fresnel color, all the different things that created in the workshop. and using the lightweight pipeline as well. So go back to some other questions. So can shaders created from shader graphs be adjusted by a code? Yes, they can. So when you have the, just like any normal material with properties, when you have these exposed, these can be accessed via code and also the animation system. Currently, although we're changing this very soon, the property names are automatically generated. So I'll show you what, I'll show you what they look like. So selecting the shader graph asset, currently the property names, such as Fresnel color, are actually generated. So here I have color_4DOD. This is just generated. However, in, I think, the next release of shader graph, which is coming out very soon, hopefully, you can actually set what the property names are, and then you just access those via script, like set float this name, get float this name. Exactly how you would do that today with current shaders. Vertex control. So this is one that a lot of people have been asking about. Currently, there isn't vertex control support. However, it's being added very, very soon. So I don't think I have... OK. If you go to that pull request, you will find... OK, yeah. If you go to that pull request, you'll notice that because shader graphs development is all on GitHub, you can actually see all the pull requests and the different branches that people have. So this pull request should show you an example of vertex position or vertex offset. So that's in development and coming out soon. Currently, you can't do it, but I assure you, go to that link, you'll see something you can download and you can play around with it. Another question, can I import my own function to use in the graph editor? Well, yes, you can. You can use the custom node API to take your function and apply it into a custom node. That blog post I showed you is very useful to learn how to do that. And grouping some nodes to one. Yes, you can, actually. I have 1 minute, so hopefully I can do this in 1 minute. OK, so when I went to the create window, you'll notice we have shader and then subgraph. So let's just call this subgraph. And if I open up the subgraph, so this is basically a kind of grouped version of a node. So if I add, I'm running out of time, so let's just say a couple of properties. And I'm going to do this very quick. So here we have a very basic graph where we have a value and a color added together, and then it's being output here. So if I now save this asset, and let's go back to our robot spider. If I now have a look here, we have subgraph assets, subgraph, and we have here that vector, that color, and then we have the outputs that are created. So you can see here that we can then create this subgraph, which does a complex amount of nodes, like lots of nodes inside here. So again, this is kind of like an input. Something's done with those values in the nodes, then the output out the other side. And in the example library, I've actually got some examples using that. So I actually think that this one here is doing just that. So here we have all the different textures, albedo, normal, going into this node here, and then they're all being output the other side. And this node looks like this. So rather than cluttering up my screen, I'm using the subgraph to compact it down and for it to be very nice and neat and organized. So this is disorganized. This is organized. So yeah, you can group nodes together. I'm in -1 minute now, so thanks for, or kamsahamnida for coming to the session. I love coming to Seoul, so I hope to see you all in the future. Thank you.